Hello, welcome back to 5 Minute of Code. This is day 9, and I'm quite late on today's problem because I was too tired to do it at 5 o'clock this morning. So time, not really of the essence today. Actually, this might not work. Okay, it does work. So the sample answer was 13. Nice and easy to pass. Up, down, left, right, and then 1 to 10, 1 to 11, 1 to 12, 13, 15, 16, 17, 19. Okay. Well, we can just A to I that. 2,000 lines. This rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. It seems to support the elves just fine though. The bridge spans a gorge which was carved out by the massive river far below you. You step carefully. As you do, the ropes stretch and twist. You decide to distract yourself by modelling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. If the head moves far enough away from the tail is pulled towards the head. Due to nebulous reasoning involving Planck lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then, by following a hypothetical series of motions, your puzzle input for the head, you can determine how the tail will move. Due to the aforementioned Planck lengths, the rope must be quite short. In fact, the head and tail must always be touching. Okay? Diagonally adjacent counts as touching. The head can cover the tail. Okay? That sounds straightforward. If the head and tail aren't touching and aren't in the same row or column, the tail always moves one step diagonally to keep up. You just need to work out where the tail goes as the head follows a series of movements. Assume the head and tail both start at the same position, overlapping. Okay? After each step, you'll need to update the position of the tail if the step means the head is no longer adjacent to the tail. Visually, these motions occur as follows. Right 4. Well, we move the head 4 steps to the right. We move the tail along at each step. Not after the 4 steps are done. After simulating the rope, you can count up all of the positions the tail visited at least once. The tail did visit the start position. How many positions did the tail visit? Okay, there is a few things I'm slightly confused about. If the head is ever 2 steps directly up, down, left or right, so 2 steps orthogonal, move the tail orthogonally, that one's easy. If they aren't touching and aren't in the same row or column, always move diagonally. Okay, that sounds fine then. So I need to work out how many squares the tail landed on. And I'm wondering whether I put these in a hash table, or whether I just mark them on a grid. But the grid could be quite large. I'm going to use a hash table. Direction is line 0, distance is 8i line 2, line plus 2. We want a hash table for that, and we want to mark 0, 0. We want so we're making a string out of these, and we just need to special case 0. And with 2,000 lines of input, where the largest number is about 20, then we can't get as far away as 32,768. So that seems fine. So to mark, if we run out of memory, I'll improve this. So we'll HD put K1. And the answer is how many we visited, which is HT used. And to move in a distance, instead of taking a direction, I think we'll take a dx and a dy. Okay, so we first add on dx, add on dy. Now, update tail. Well, I'll just put it. Well, update tail. And then we'll have dx is head x minus tail x, dy is head y minus tail y. I don't think I have an abs. So if abs of dx is less than or equal to 1, and abs of dy dy with some to 1, we don't need to do anything. If alpha dx is 0, moving y, else if alpha dy is 0, moving x, else move diagonally. In fact, I think in all of these cases we possibly just do that, because that's it. So we update tail and then we mark y. And we've already marked 0, 0. Maybe that's it. Oops. Ugh. It was just dots above, wasn't it? Oh no, that's not the... This is the input. $14. It's suspiciously close. What's the easiest way to check that it's doing the right thing? Is there a shorter sample? Oops, illegal. So if we go right 4 and then up 1, the answer should be 4. It says 5. Oh, why is tail at 3, 1 and 1, 1? Did I write an X when I meant a Y? Oh, if X is 0, the sign is 0. might have been worth compiling it for this one. Out of memory. No! Okay. Okay, this is... what we can do is... when we look up the key, get KV, okay. I think it's get KV. And then if KV, will 3P, okay, KV0. Otherwise we return K. I will just check that. That way we reuse the existing key if we already have one. Oh, actually, this is a waste of time. I should have just compiled it, and that would have probably freed up enough memory. Get KV, return key val. Okay. I will recheck it on the sample, just to make sure I didn't write a bug. Wonder why this is so slow. Probably all the hash table stuff. So another idea might have been to run the program once. Okay, this might be the better idea. Run the program once, not counting the squares you visited, but just print out the bounds of the grid that the movement is within. Okay, well, we'll have to do that then. And then create a 2D array that is big enough. So no hash table. Let's comment it out because it is possible that I will want it back. I really need a way to get the editor to... Actually, let's just not comment it out, let's just not use it. And what we'll do is x equals minutes, x equals x, x equals max x, max x equals x. And then at the end, oops, delete. So this should go quite a lot more quickly. It's not going that much more quickly. Maybe it's because we're doing a lot of magnitude comparisons. Okay, how big is that then? 400 by 200. 80,000. This is actually going to work. Minus 68, minus 108 to 307, 106. So we'll do two things. Firstly, oops. Firstly, we'll get rid of the hash table stuff. We don't need minx and max y anymore, I don't think. Actually, we do, but we'll hard code that. Minus 68. Minus 108. 6. Visited is now going to be bitmap. don't know if the bitmap code. It doesn't matter. We're not going to use the interpreter anyway because it's too slow. Okay, so I expect it just wants a width and a height. Mark. So to mark a square, we simply bm set visited x minus min x minus min y. And then at the end, we want bm count. We don't need this, and I'm going to make update tail better. So instead of abs, what we'll have is these are close. And we'll write in assembly language. So we want to know is x minus 1 0 or 1. So return 1 plus return 0. That should do it, I think. Compare x with 0, 1, 1 and minus 1. JZ jumps if it's equal. If we didn't jump for any of them, we return 0, otherwise return 1. Okay, and for the sine function, we can do something similar. Return minus 1. And then we want if it's close to x, that's 0. If it's close to y, that's 0. And then all of those magnitude comparisons are gone, which is good. But it's more likely to be wrong. I've written it part 1 in .sl instead of part 2 of .sl again. What I can do is not save it. The editor doesn't have a way to save under a different file name. Incorrect. Oh, it doesn't exist. So takes width followed by height, takes xy followed by value, and count tells you how many is set. Okay, so I'm using that correctly. Maybe I shouldn't have tried to write this in assembly language. may have to tend to the baby in a second. What are we going to do here then? Well, let's test this stuff. Okay, well they all look correct. So I don't think it is the assembly language stuff that's wrong. Maybe it is the bitmap stuff. Maybe this needs to be +1, although wouldn't matter for the sample input. I've accidentally, this should be that. Boolean operators don't short circuit in slang, which is why it's preferable to write 2 ifs rather than if is close to x and is close to y. Oh, it is still part 1. Why did I think it was part 2? I think I felt like I'd moved on to a different problem when I switched to doing it with the bitmap and the assembly code. So this should work, but it is actually part 1. And it seems to be proceeding much faster, which is good. Okay, good. But all of this stuff is actually part 1. Right then. Oh, I think we're saying run the same input 10 times. Suddenly the river is getting closer. 2 knots. Oh! We have 10 tails. Okay, fine. We'll have to do the thing again where we work out what the bounds are in a first pass. Minimum is maximum. Maximum is minimum. Minimum is maximum. Maximum is minimum. Mark doesn't do this. Mark says okay, at the end, so that we bounds. Now, instead of just one tail, each tail is a head for the following tail. So Oh, interestingly, we only need to mark when we update. Because if we didn't change it, then it was already marked. Now I'm guessing the way this works, well, there's only one sensible way for it to work. What we'll do is say head x equals not x I, y equals not y I. Do all this, and if I is less than something, update tail I plus 1. So what is something? 8. 9. If it's less than 9, no, if it's less than 8, we can update tail. No, if it's less than 9, we can update tail 9. Fine. We can't have a var inside here. Seems believable, I think. I didn't note down what the part 2 sample answer was. Oh, that was really dumb of me. The bounds are exactly the same. It's not possible for these knots to go outside the bounds from part 1. Ah, silly. Obviously, because they're following the head from part 1. Did update tail still take an argument? Just check that. Update tail, okay. Fine, that's gonna work. $16, is that right? Wow, that's long. I just want the end of it. Oh, it doesn't tell me. Now the tail visits 36 positions at least once. Oh, but we only want the very end tail. Hang on, I've implemented the wrong thing. I think I should have read the problem. Right, we have a rope consisting of 10 knots. 1. Oh, no, that was right. Right, okay, just read it slowly. A rope snaps. Suddenly, the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you now must simulate a rope consisting of 10 knots, which is what I've done. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. That's what I've done. Now you need to keep track of the positions the new tail, number 9, visits. In this example, the tail never moves. More types of motion are possible than before, so you might want to visually compare your simulated rope to the one above. I don't think any more types of motion are possible, are they? Oh, the larger example is different. Okay then, what I'm going to do is fix the program. So that we only mark the ones that the actual tail visits. And we'll get the second sample. Now we get to do an O of n squared, delete lots of lines in the editor. It's O of n squared because instead of freeing all of those lines and then shifting these lines up, it frees the first line, shifts everything else up, frees the first line, shifts everything else up, and so on. But I don't do it frequently enough to mind. One. Incorrect. What is the problem here? Oh. Because I refers to the index of the head, not the index of the tail. Excellent. Now, how long is this going to take? Still, it's quite a lot faster than the hash table version of part 1 was. I can tell roughly how fast it's going by how frequently the disk access light comes on, because that tells me how quickly it's getting through the input. Whee, great success. Well, that was good. It was a good job time was not of the essence, because I would not have done particularly well. How are we looking now? Back in second place, that's good. Now with a 30-point deficit. Never mind. I think Ichabod might have it this year. Maybe he had it last year, can't remember. Actually, I can find out. Oh yeah, I didn't finish them all last year. Alright. Good stuff. Thanks for watching. Goodbye.